Well, hi, good morning, and thanks so much for joining me here in my shop today for a very rainy day, but I shouldn't say too much about the rain here because the sky is flooding out on the west coast. It's just pouring out of the sky on the west coast of North America right now. So a bit of rain here, I can't be complaining too much. Now, quite a number of things happened during the video yesterday and afterwards. So let me just talk a little bit before I get going here. First of all, on the resistor thing. Finding these resistors so high, and all of them the same way high from their proper value is very, very interesting to me. It's very, very curious to me what has happened with them. And in part of investigating that yesterday, I tested other resistors. What you didn't see was another 20 or 30 minutes of me testing many, many resistors in my shop to find any other situation which was similar to these. And I couldn't. Here's just an example. I have quite an extensive collection of resistors I've managed, fortunately to me, to acquire over the years. So these are some I seldom pull out. I have others here and there and everywhere. I had lots to test, which I did. And the result was everyone I tested was really very close to the marked value. Very close. Except these, which are the ones that I wanted to use. So just in noticing, as pointed out to me and was certainly in my head, it's a silver band resistor. There's a range of true values which can carry this label, right? And the silver indicates there's a 10% range around the value on here, and 520 is just getting right out on the fringe of that range. The interesting thing to me is that all these tested the same. That's the part that gets me a little bit crazy. It's possible in the factory when they built these that their systems were running a little bit off and they were producing these resistors at the value I measured it, but it's still okay to label them as 470 and stick a silver band on them. I don't really know for sure what's going on in those factories or what was going on back then. These guys will go high over time. My own personal experience is they never go down, they always go up, and that sitting in a tray here doesn't cause them to drift over time. So that's been my experience. Now others have other experiences. We're living in a world full of anecdotal stuff that we have to somehow work our way through. We can't be doing, double-blind scientific experiments every time we turn around to prove things out. But just to point out that this resistor has a gold third band, this one has a silver third band, so this should be more precise, more close to its value. A lot of my resistors are gold band resistors, but a lot aren't. I do have a large number, and I don't know if I can grab them right away. Here's some of them. A large number of truly older resistors here. I've got a pile of dog bone resistors and whatnot, and maybe someday I'll put these to the test and just see what's happened to them. They're much, much older than my normal stock. I don't think these are very old, but I don't know. They could be from the 90s. They could be from the 2000s. I don't know how old they are. Okay, but that's not really the problem in the end. The problem is not the resistor there. While I was working on the resistor, and this often happens, because your attention is drawn intently to a certain area, you start noticing other things. And you might remember I wiggled this capacitor here a little bit. I think the close-up camera was running then, and I'm looking very close at how it was soldered. I wasn't too happy with what I saw, but I concluded that, well, it's connected. Now, what I did here, because this is a solder to the chassis spot, I try to avoid resoldering things to the chassis. That's a tough go. You need a big, strong soldering iron with lots of heat energy in it in order to do it. So what I do, I cut, I'm sure most people do this too, doing this kind of work, I cut the old component out and leave its wire there as much as possible, so I have a tail to solder to. so I don't solder right down to the chassis. Came in this morning thinking, well, I really should fix up that capacitor soldering. I mean, it's right on the tube that I'm having trouble with, the circuit I'm having trouble with. Goodness knows if it was really on there, so I decided to check it again. I just reached in and went like this, and I went pop, and came right off. So it's off. Maybe this is the problem. So the bad news is really the good news, that could be the problem. Now another angle on this are these very curious capacitors that stand out in the video. These ones here, 5A, 1A. So a year ago, when I began investigating this oscillator problem, one of my targets right away were these capacitors. One of them I disconnected. It's 1A here. The disconnection was there. And I measured it, and it was okay. So these are quite precise, if I remember right. I have to look in the schematic again. And I remember thinking, oh my God, I have to replace, if I'm going to replace these, I have to replace it with exactly the values that these have. I suspect these might have even been built for this radio. I'm not sure of that now. I don't have an absolutely exact replacement for these, which appear to me to demand very precise values. If the capacitor is drifted a bit, without looking at the schematic and thinking hard about it, probably that would just cause the oscillator to be a little off. It wouldn't stop it completely, unless one of these is open or shorted, and they're not. They're not open and they're not shorted. So I kind of passed on that, because I think I put this resistor in, I think at the time. There's another one up here. Trying to remember now why I did that. Could be because I didn't know what else to do. I must have measured the resistors and found them a little bit off. In went some new ones. So in a problem like this, where the oscillator won't oscillate, everything I do makes me nervous, a little bit nervous with it, because I could accidentally introduce another reason for the oscillator to not oscillate. So for instance, this resistor, the 470 here, if I'd replace this with one of these guys, saying to myself, well, there's no reason for it to be that precise anyway, about 470, 520, what could the difference be? And I put this in, and it turns out that this in fact is a critical element, that 470 really is exactly the resistor value that needs to be in there, which I kind of doubt. But if that were the case, I could introduce a new cause for non-oscillation. Now I've got two problems in there, one of which I made. That's what happened with this capacitor. And good luck to me on finding that down the road. That's really a real challenging thing to sort that out. So I'm really anxious about introducing more trouble, particularly because I don't understand why it's not oscillating. And you know, this is the problem. You're waiting at the church and somebody hasn't shown up. You're wondering, why haven't they shown up? You don't have any idea. It could be anything could have happened. The same thing with why the oscillator here is not showing up. It could be almost anything. So first of all, I'm going to fix this. I'm going to solder this capacitor down like it's never been soldered before. It's not a tall order. And then we're going to check the radio and see if that in fact wasn't really the problem. Something that maybe was unimportant at the lower frequencies but became quite important at the higher frequencies. And the other thing is, my God, so you will hopefully have seen an improvement in the video quality of my videos, and I've unfortunately accidentally allowed the quality to drop to 720p unnecessarily, and I sorted that out, and it was actually quite a bit to sort out everything, to get everything running now at 1080p where it should have been all along. Came in this morning, went and cleaned my glasses, turned on my stuff, looked up at the screen and went, oh my God, my glasses were part of the problem here. So if you tend to walk around with dirty glasses, don't. I'll have to make that just a standard procedure now when I come in my shop. Clean my glasses and see things for what they really are. Yeah, okay. Now, so as I said, the first thing I'm going to do is resolder this down and check the radio for operation. And, if it works, great. Great. Embarrassing, but great. Okay, I'm very securely soldered in that capacitor, so no problem there now. But here's another thing. And what did I do here? So these two resistors that I've got in here at what's white? Is white 8 or 9? Maybe it's 9. 39K. Another one up here, 39K. So on the schematic I was using, it's very, very hard to read any details like values in that. And on there it could be 39, it could be 30 anything. It's really hard to tell. But there's another diagram, the diagram that shows the wiring. And on there it's quite clearly shown that these are 33s. So I took a bit of time and hunted down a better copy of the schematic. It's still not great, but it's better. And 33 is what these should be. These got to be fairly critical, I would think. So I'm going to change these out to 33s. That'd be orange, orange, orange. And then we will have done two changes. I should test this radio before I do that. Maybe I'll test it when it's working now because I fixed the capacitor. Maybe that's a waste of time changing those. Yeah, let's test the radio. Give it a test. It'll just take a moment. Find out if somehow I fixed it. And the method I'm using to detect whether the oscillator is operating or not, that's an interesting term to use, isn't it? To detect if the oscillator is oscillating. Is simply listening to the radio, and if tuning it makes no difference, I'm assuming the local oscillator is not there. I think previously I've proven it beyond a doubt the oscillator is missing. So I'm just going on that observation. There could be problems with that too. Problems at every turn. Here we go. I think everything's okay. Some famous last words there. And we'll give this guy a moment. Everything looks good, so we'll give him the full Monty. So I guess I've been lucky all these years. I've seldom had a radio that had really serious oscillator difficulties. Bonnie's up here. Something's not too happy. I'm guessing that's a tube doing that. Something internal, some kind of internal short going on, maybe between the heater cathode or who knows what. Pretty hard to tap it out, I think. Well, what did I can't even see what I just tapped. What did I hit there? I hit this tube. Awkward, getting my hand in there. Well, I'm guessing it's the grid cap connection's bad. Okay, can't deal with that right now. Can't imagine that's the cause of problems here. AM band. Tuning. Next band. No antenna. I think I left my antenna switched on here. Yeah, that's tuning. Next band. Yeah. Can you hear something happening there? Not here. Not here. So that's pretty clear. Okay, so soldering back that capacitor didn't solve the problems. And fat chance this resistor is going to solve the problems too. But oscillators need everything to be just right if they're going to oscillate. And yeah, so we are exactly where we were. My next best move, I think, is to test the vacuum tubes, even though I'm quite certain they're good. That's just what I have in my head, so I'm just going to go ahead and do that. Test the oscillator tube. I think is really the only one that needs testing here. Spending a lot of time out of the shop this morning, but I came in and thought, you know what, I really should change these resistors. So I'm pretty convinced they should be 33. For reasons I don't recall, I put a 39 in there. What does it actually measure with? Now, it's still in the circuit here, but the one end of it just goes nowhere. It goes to a 2-pin, goes to a capacitor, so I can read it like this. It's supposed to be 39 and 42. It's supposed to be 33 in fact, but it's 42. Wow, that's really a significant difference. Now, could this be causing problems? Maybe. So now that I've been whipped so forcefully on resistors, here's a possible replacement, a smaller one, smaller wattage one. But it's orange, orange, orange. What does it say? 37. Well, it's a silver band, so it's probably within range of what it's claiming. But is that really what I want to put in there? I have these ones. Look at that. It says right on it 33K. Fantastic. But I think these are wire wound. I'm not sure. Surely to goodness, putting a wire wound resistor in there, well, who knows what would happen. So here's another 33. I think I've been assuming resistors are more reliable than they are. But very odd after testing so many resistors yesterday that here I am again. The ones that I'm really concerned about are the ones that seem to be off. So this is another 33. Put a new battery in my meter too here. 35, so it's closer. Just for fun. Let's just test the big one here. Oop, I was wondering how I could determine if these were wire wound. Their physical size is a bit of a giveaway. I can look at them and I can see a spiral shape under the cover here, which I imagine to be the spiral resistive wire. There we go. 33.9. 34. Well, the story, it's a sad story. These hundreds and thousands of resistors I have, I do not have a 33 of this size. Son of a gun. Here we go again. Well, I'm going to keep hunting around here and just see what I've got. That's going to be very close to the 33 it's supposed to be. Jeepers. Yeah, hard lessons learned late in life. So here I have two fairly good quality 30K resistors, and they both test at 31. It's our gold band. Gold band means 5%. What's 5% of 30? 5% of 30. 1% of 30 would be 0.3 times 5, 1.5. Well, that's within the range, even though they're a little out. They're close enough to 33, I think. That's what I'm going to do. I'm going to put these in. I don't expect it to make any difference, but I have no way of knowing until I've done it. So I'm going to put these two in. I don't even know for sure that these two resistors are implicated in the bands that are involved. The switching arrangement in this radio is complicated, and I'd have to stare at a very bad. I've done this already. I did this, 8 months ago or 12 months ago. Stare at the schematic for a long time and try to figure out what is going on with the switches. Okay, I'm gonna do the other one and solder them in, and we'll test the radio and see what happens. Okay, ready for the test. Volume is turned down. Switch is on. Let's go with the dim bulbs briefly. Okay, no problem there. Just connected the radio to Niagara Falls. Let's see how we do here. We'll start AM band. Tuning without a doubt. Next band. Tuning. Next band. It seems weak compared to the others. Now, I'm in a short wave band, the wrong time of day, maybe. The strength of the signal that comes out of the speaker is based on a combination of the antenna signal and the local oscillator being mixed. If either one is really weak, the output is weak. So if the local oscillator is failing on the third band here, still working but become weak, I would get this kind of result. That's not very good. Let's just go. Silence. No tuning effect at all. Okay, so these were long shot things. Changing these resistors, it's kind of a long shot. The sounds we're hearing are probably going straight from the antenna through the IF at the IF frequency. As there's noise everywhere. Okay, so those things are out of the way now, I think. Yeah. Oh, heavens, what was that? Oh my gosh, you know what that is? I'm not going to repeat it, but it's me swinging the radio and making the frame touch the frame of that speaker. Getting that big pop. What's happening there? Quickly. Shock hazard, shock hazard. Let's just find out what is up there. I did not like that at all. There's a shock hazard there. Boy, I need to know about it because, wow. Okay, so we're on just DC volts here. Are you working? Let's find out. DC volts 200. Let's put it right up to 1,000 here. We're right on the power supply capacitor. Wow! What was that? That's what happens when you have the volume up full. I was not expecting that. Okay, give a little bit. Am I doing something stupid here? I don't think so. Why so sensitive? Is that true on the other bands? Other filter capacitor. Ooh. Okay, let's just ignore all that. What's going on here between the frame of the speaker and the chassis? Well, maybe it's the 14 volts. So that's suggesting there's an AC voltage there, I think. Really? Could there be? Could there be? A bit of trouble making a connection here. To make of it, but if the radio is so sensitive that doing this, I don't get that. I don't get it. Okay, but I don't know if it's a problem. It's just something I never observed before, or what. So the real suspicious thing would be, oh there I am touching it again, would be these capacitors here. Now last time around I separated one of them and measured its value. The value was right on. There's no reason to think there's anything wrong with them, and I've left them as is. I just reconnected the one I disconnected. These, one of them is 96.5 picofarads or whatever it is, 96.5. That's very, very precise. And so I've been extremely hesitant to change these out because of it looks like they must be precisely right. They are very unusual looking. I've never seen a capacitor like that. I suspect they are made for this set. Don't really know. So that's why I've been hesitant to try changing them. But I'm probably going to end up there. The next step, though, is to verify the tube, and I have read numerous times that in a case like this, with an oscillator that won't oscillate, regardless of the tube test, you should try other tubes. And just sometimes you might have to try 3 or 4 tubes, and then one of them will work. That's kind of an old style of doing things, but what else have I got here? And a very high voltage in the power supply, the 440 volts, a little higher than I expected. Could be because the rectifier I'm using here is a nice brand new rectifier. It may be allowing for a higher voltage there. Again, consequential? Don't think so. I put in, what size capacitor I put in? I think I put a 450 in there. It's right up at 450, isn't it? Ooh. Okay, tube testing. Okay, here we go. Oh, 6J7. Let's just double check here. 6J7, 6.3 volts. 2, signal level 31L. A 1, a 2, or a 3? 1. 17342, 17342, 0610, 40 D 800. If we're happy at 800, happy there. Okay. Just give that. Everything a moment here. Very hard to light my tube tester so you can see the dial. Okay, let's look for shorts. The short test to some degree is protecting your tube tester from a shorted tube. Nothing showing up. 800, here we go. Well, it's up around 1100. Well over the 8. Okay, that's not helping. I do not have a lot of these particular tubes. In fact, I don't know if I have any to try swapping, but there's another one in the radio, and we might as well test it. Anyway, it's part of the frequency control system. Let me put this one right back in. And of course that circuit and this tube could be somehow implicated in this, and I just don't realize it yet. So let's give it a test. That's definitely a 6J. Yeah. 6J7. Give it a moment. Warm up. I suppose by rights you should really let tubes run in a tube tester like this for at least a few minutes to get them really fully heated up. But no time for that. Better than the other. I think I'm going to swap these. Well, at least I will have done something to cause a change in the operation of the radio. I'll swap them. I will swap them around. So when I'm making these videos and things are happening and funny things happen like that noise between the speaker frame and the chassis, or me touching the filter capacitor positively and getting a big noise out of the speaker. I'm hoping people will make comments about that, because you may have, like you as a viewer, may have insights that I don't have. And so I'm trusting that there's some amount of discussions going on in the comments about things like this. I just can't deal with absolutely everything that comes up in front of me when I'm doing this, or this will be the last radio I ever fix. So have at it on the comments. Now, tubes are switched, caps are on. We are ready for another test. I would say the chance of this making any difference is just about nil. Right to full power. We'll go down to the lower band. Start there. I should really investigate whether the third, I think there's 5 bands, the third band, the 2 top ones not working. Third one seemed weak. Should really look into that. It's tricky to test an oscillator. It's very tricky to test it often. I think reading current flow is the key, and that's something. Oh, I took the antenna off. There is no antenna. That's right. Let's put it back on. Volume's turned down. You can uncover your ears. Famous last words again. Okay, I think I got that on. Yeah. So there we are. No question. Working. Lots of volume. Lots and lots of volume. Next one. Something going on there. Next one. I wonder if it could just be that this head is out of alignment, and that's preventing the oscillator. So this is potentially the weak band. It's really not very convincing, is it? If there's a weak one, That might help me source the problem. I could find the sensitive spot. That could be a great advantage. You know what? I'm not really hearing much action here. They have another way of checking for the local oscillator, which I will do next. Top band, it just goes silent again. Guess the idea there is there's no local oscillator, there's no conversion. Ooh, what's all that? There's no conversion to the IF frequency, so there's nothing to come out except what I guess we could call IF frequency noise. Well, what did I say I was just going to do? I said something I was going to do. Set up to be more aware of what's going on with the local oscillator. Let me do that. Okay, it started making the sound again. Let me just tap that one tube. Pretty sure that's the deal. I'm going to ignore that. Yeah, I said I ignore it, but it's not ignoring me. So this is the tube. Must be a pin problem. Which one? Something internal in the tube? Okay, can't ignore it. It won't let me ignore it. I'm going to pull that tube out and stick it back in. I could just leave the video running. Power off. Oh my gosh. Oh my my. It's a little warm. Okay, so that's probably enough to... Just looking at the pins, nothing unusual about them. You know what? I think there's some play in this. Yeah, there's a little bit of play in this. Did that cause a problem? I just don't think so offhand. Okay, stick it back in. What is it anyway? Huh, I can't read it. Okay, hopefully that'll settle that tube down. Here we go. Watching the dim bulbs for a moment. All is well. Go back to the AM band. Tons. Okay, got quieter, got away. And the secret is this band. You see, I can hear a little bit of tuning effect. Not too impressive. Okay, that's not the best way to check something, but and then we go to the next band, the two duds. They don't want to work. Okay, so I'm going to continue. I'm almost done. enabling us to see the effect. In fact, I can do this. There we are. Now, so I want to show the local oscillator on my SDR that you're looking at now. So we'll jump down to the AM band. Now I didn't show you this on camera, but I have a little loop. I'm waving around. Wow, you see that thing show up there? That's me waving this loop around. It just has to be in the realm of those oscillator coils. Okay, it's hanging. I'll tune the radio just to prove the local oscillator. There you see it moving around. Okay, now we're going to go to the next band. Now the next band is what? Next band is, I'm not even sure. I think it's 6 megahertz. Let me look. Oh, look. Well, that's the next band up in frequency, and I assume they've done this that way. So if we're tuned roughly in the middle, we're tuned roughly to 6.1. So 61500 is where we should find it. 6.1. That doesn't make sense. 6.1. Yeah, there's a big thing right there. Is that it? I think it is. Okay, so if we were tuned to 6150, we would expect this to be 455 away from it, maybe below. There you are, below. Let's just look. 6150 and above would be just maybe off the screen a little bit. No, there's nothing up here, so it must be local oscillator below. But it's there. Okay, next band. Following along on the idea that it's just going to go up in frequency, not jump around, we be tuned to 9.6 right now. So if we look at 9.6, well, there's a great big thing over here. So we'll go over 9. If we're tuned to 9.6, this is way off. This shouldn't be there. It's like, wait a minute, I'm not talking right. It's right on. Right around 10. Now tune the radio and we'll see if it moves. There it is. Okay, so that's filling my SDR screen plenty strong. It would look like. And this is very much a qualitative test. Now we're going to go to the next band. The next band. You know what? The light is on for 11. 11. Not 9. So strange. Well, let's just go up to 11 and see what's going on, man. There's that crazy rabbit hole again. Okay, let's move this over. If it's 11, we would see something around here. This is really odd. The actual frequency would be 11.85, so we would be, it's easily going to be on the screen here. I'll just tune it and see if anything moves. Okay, everything moves. The theory here is a weak local oscillator, but what was happening down at 9? Wow. Okay, let's get a little precise. I'll tune it to the middle of the band, 11,800. Okay, so the dial reads 11,800. 455 below would be 11,350. 11,350 is right in this area. And above would be, so much arithmetic, 12,250. 12,250 is up in this area. Okay, tune in the radio. There's one in either one. Pick your choice. Oh my god, this is just, I got 1 foot in a rabbit hole now. How weird is the lighting on this? Didn't I do another radio just like this and it turned out the band switch lighting didn't match the bands? Oh my gosh, what would that lead to? That would lead to some pretty sad alignment work if somebody didn't figure that out. That's just hard to believe. So you see pretty clear what light is on and which band is lit up. That's the 11 band. Let me just... Okay, so that would be broadcast, which the light doesn't work. I should fix these lights. They're screwing. I don't have lights. It's the next band. Oh my gosh. That supposedly is 9 now. This is and then 6. 6, 9, 11. See, is it possible? It goes, let me look in the manual and sort this out, because this is really quite weird. It looks like it goes from AM to the top shortwave band and then comes down in frequency. Well, it could be the case. That has big implications for what I'm doing here. Well, there it is. This is the control I'm turning. You can see broadcast band where I think it is, and then it goes 49, 31, 25, 19. So it's 6 megahertz, 9 megahertz, 11 megahertz, and 15 at the top. And the lights do not follow that pattern. So it should be lighting the middle, and then a bottom upwards to follow this switch. Let's look at those lights again. Okay, so we'll go down to AM. That's where it is right now. It's on the AM band, so it should be lighting this center one. Then we go to the next band up. It should be lighting this one now. Next band up, it should be this one. And next band should be the one that was just lit, not this one. And then the top. Wow, these lights completely reversed up here? Is that what it is? So this should be top. The next light should be here. The next light should be here. Like, they're absolutely backwards. Oh man, how can this be? How can this be? Oh my gosh. Huh? Okay, both feet in a rabbit hole now. My head is just level with the ground. Man alive, this is my SDR antenna arrangement. These are the oscillator coils, so just anywhere in the realm. Holy smokes. So I did do another radio very much identical to this pretty well, with the same very fancy dial with the separate lights and all that kind of stuff. And am I wrong? That radio was mixed up too. Or am I thinking of this one? I don't know. In any case, that radio doesn't matter. This one matters. Oh my gosh. You know what? I think that's it for today. I didn't get anywhere, really, except to discover that things are not what they purport to be. Oh my gosh. Yeah, that's it. Just going to leave it at the oh my gosh. Thanks a lot for watching another crazy video here from my shop on a crazy radio. Driving me crazy.